It wasn't me, I didn't do it. Let me show you how we got here. It took a couple of days of taking this whole thing apart and flipping it over to see what's on the inside. I took a lot of pictures while taking this apart. I'll flip through them quickly. If anything interesting comes up, I'll pause and say something. One of the main reasons I took all the pictures is so I know how it goes back together later. A few of the plastic spacers on the bellows are cracked. I may have them remade on a laser cutting machine at Send Cut Send. I use them all the time at my day job, and their quality and price is terrific. Our first look at the servos. I really like machines that have belts. They are much more compact than machines that have couplings. The servos are brushed DC motors with an encoder. This machine is serial number 19. This was a young company when they built it. I checked their website, and their current machines use a different design built on top of a granite plate. At my engineering day job, every time we make a new version of a product, we always try to make it better than the prior version. I'm sure this company does the same and has iterated and improved over the years. That said, this early design looks great to me. I was surprised to see only 2 screws securing each motor. It seems the reason may be that it was designed to accommodate both a round and square motor flange. I will try to reuse these motors. If I can't for some reason, hopefully a standard NEMA 23 motor will fit into these slots. I was looking for a way to tilt this machine onto its side in order to access the bottom. All the axes have their linear rails extending from the body of the machine, and I did not want to rest the weight of the entire machine onto those rails. The Y-axis has this structural plate. Here's the back of it. Its function is to support the machine while on its side. I was trying to separate the spindle from the machine and needed to disconnect these wires to do so. I couldn't disconnect them from the motor end, so I put the spindle back together. The structural support on the Y-axis did its job. I don't know if this machine came with a box that's missing. I kind of think most of the guts are in here as far as the power supplies and the servo driver. I've been trying for a couple of days to get this apart far enough to get to the bottom of this because it's so heavy to handle by myself. Now the question is, do I rip all this out and start from scratch, or do I keep any of it? Looks like a couple of power supplies, relay, wiring, and this is the brains, the computer. Probably to interface with this. I don't know if I'll be able to do it with anything off the shelf. This custom PCBA has all the servo drivers, relays, and it might even have the pulse generation built in. I don't know if that was done on this board or on the control computer that would have been attached. This whole time I couldn't disconnect this wire and this wire. I didn't want to take this apart to do it. It was too much work. And you saw how much I struggled tipping this because of the spindle. So now I'm going to trace all those wires over here and pull them off so I can pull the spindle off. And then I'll have to take an inventory of all this stuff down here and decide what's worth keeping. I know the power supplies are good, but this is going to be the biggest hurdle. So either strip everything out and start from scratch, or try to interface into this computer. It says Levil M10, so it looks like it's their own proprietary board. There's no way I'm going to be able to interface with that, I don't think. I'd have to buy their software and buy their stuff. And actually, I contacted them, and they don't even support this control anymore. They said I can upgrade to a Fanuc control. So I'll probably replace this whole thing with a board from UC CNC. They're only $150 or $200. I think trying to figure out all these wires and all this stuff up here, you know, I'm sure it was good originally, but now to trace all that, it's just going to be probably more trouble than it's worth. I do like how they integrated all the electronics into the product. It makes it pretty nice, and it looks like everything's really clean down here. The housing material kept it clean. And also, it looks like my granite epoxy design, I'm probably way overbuilding it. I mean, it looks like C-channel aluminum, but the wall thickness, I can feel it. It's about 3/16 of an inch thick. What I was doing on mine is 1/2 inch thick wall thickness filled with epoxy granite. The heart of this machine is this aluminum extrusion, which is about probably 30 millimeters or 1.25 inches. And now I know what's on the bottom, so now I'm going to strip everything out, clean it up mechanically, and figure out what I'm going to do from a control standpoint. Well, I killed the machine. Thanks very much for watching. I'll catch you guys on the next episode.